Welcome to the welding module. Press start when you are ready to begin. You can now start welding. Press the finish button once you are done to look at the results. The results of your current session are shown on the display in front of you. Welcome to the welding module. Press start when you are ready to begin. The results of your current session are shown on the display in front of you. Welcome to the welding module. Press start when you are ready to begin. The results of your current session are shown on the display in front of you. Welcome to the MIG welding lesson. MIG welding is an arc welding process that uses a continuous solid wire electrode heated and fed into the weld pool from a welding gun. The travel angle is an important factor in welding because it can affect the welding process, and voltage determines arc length as well as the height and width of the bead. Some welding machines come with a chart for setting to proper voltage. The wire speed controls amperage as well as it affects the heat level. A speed that is too high can lead to burn-through, and if the feed rate is low, the weld area can run too cool for good penetration. Material thickness determines amperage. Select proper wire size according to amperage. Stick out is the length of unmelted weld wire extending beyond the end of the contact tip. Stick out should be around 1/4 to 1/2 inches from the weld gun. This brings us to the end of the MIG welding lesson. Welcome to the stick welding lesson. Stick welding refers to a welding method where a filler rod in the electrode holder serves as the welding electrode. A welding electrode is a fixed-length, straight welding wire coated with a filler material. The letter E indicates electrode. The first 2 digits refer to the tensile strength of the electrode. The third digit indicates the position that the electrode can be used. The fourth digit indicates the flux coating and the current to be used. Stick welding in the flat, horizontal, and overhead positions uses a drag or backhand welding technique. Hold the electrode perpendicular to the joint, and then tilt the top in the direction of travel approximately 5 to 15 degrees. Traveling too slowly produces a wide convex bead with shallow penetration. Excessively fast travel speeds also decrease penetration, create a narrower and/or highly crowned. Keep your arc length short. Your arc length shouldn't be longer than your electrode diameter. If your arc gets too short, then you're going to lower your voltage and stick your electrode to the workpiece. The correct amperage setting primarily depends on the diameter and type of electrode selected. While stick welding, the voltage is determined at the arc, not at the welding power supply. To create a wider bead on thicker material, manipulate the electrode from side to side, creating a continuous series of partially overlapping circles, or in a Z-shaped, semicircle or stutter step pattern. The welding is started by sharply striking the bottom of the groove with the welding electrode. This brings us to the end of the stick welding lesson. Welcome to the TIG welding lesson. TIG welding is an arc welding process that produces the weld with a non-consumable tungsten electrode. Polarity refers to the direction of current flow when welding. Polarities mostly used in TIG welding are direct current electrode negative, recommended for welding most of the metals, and alternating current for aluminium welding. The electrode material should provide a combination of the following characteristics: low electrical resistance, high melting point, good emission of electrons, and good thermal conductivity. Amperage is set according to material thickness, and can be operated by a foot pedal. With the scratch start ignition, the electrode is scratched on the metal to initiate the arc and must be quickly lifted off the metal to try prevent it sticking. The lift arc ignition involves bringing the electrode down quickly and lightly into contact with the metal to draw the arc. The high-frequency ignition allows the operator to position the electrode near the metal and simply press the foot pedal to start the arc. Post-flow helps assure the weld is protected as the weld pool solidifies and shields the electrode from atmospheric contamination as it cools after welding. For proper post-flow, hold the torch over the end of the weld until gas flow stops. Arc length from tungsten electrode to metal should be around 1/8 inches. Hold the TIG torch at 75 degrees angle, and the electrode at the point where the metal will be heated by the torch so that it makes a 15 degrees angle with the base. The suggested travel speed for TIG welding is 4 to 6 inches per minute. This brings us to the end of the TIG welding.